For this problem here, we're asked to find the equation of the tangent line to this curve at this point. And in this course, if you're just asked that, is not told algebraically, I can just go straight to my calculator. I plug it in, and I can just go and actually draw my tangent line 5. Now I'm going to draw my tangent. Let's see, y1, comma 4. Interesting. In this example, we're asked to find the equation of the tangent line to this graph at this particular point. And in this particular course, applications, if we're not told to do it algebraically, we can go straight to our calculator and find it here. So I've already taken the liberty to enter it into the calculator, and I can graph it. And if I go second draw menu, 5, if I just go when x is 4, I get my tangent line. And so I can see that y is equal to negative 0.1875 x plus 2.75. And it always says to be the exact value or correct as 3 significant figures. And this is the exact value, so I don't have to round it. I can leave it as such. However, and if I clear that graph, to get rid of the drawing, just to reiterate, if I go to draw again, I'm going to go number 1, clear the drawing, it'll be gone. But if I had to do it algebraically, and I'm going to try and find the tangent line that way, I'm going to take y and I'm going to rewrite it as 8 to the 4 plus 3x to the power of negative 1/2. Because when I pull this up to the top, it changes the exponent and I can make it a exponent so I can use the chain rule. So now when I do dy dx, I'm going to pull down, doing the chain rule. I know this comes down, so it's 8 times negative 1/2 times 4 plus 3x, subtract 1, which will be negative 3/2, and then times the inside derivative, which is 3. And I want to find this when x is equal to 4 to find the slope. And so if I simplify here with some arithmetic, I know this cancels, it gets 4. And so I can say that this is 12 here. And if I plug the 4 in, it's going to be 4 plus 3 times 4 to the power of negative 3/2, which is going to be 12 times 16 to the negative 3/2. Well, if I go 16 to the power of negative 3 divide 2, and I multiply that times 12, I get 0.1875. And I just realized that I forgot this minus sign here, so I'm going to pull it in. That should be negative. And if I take that, I can convert it to a fraction, work it in fractions, and I can say that my slope is equal to negative 3/16. If I plug it into y minus y1, my point is 4/2. Is equal to minus 3/16. X minus 4. Multiply everything by 16, so I get 16y minus 32 is equal to negative 3x plus 12. And if I rearrange this, I'm going to bring the 32 over, minus 3x plus 44. All of this is over 16 would be the equation, and that looks that these will be the same value as such. And so you can do it algebraically or with your calculator.